All right, good morning, everybody, and Elementary Calculus 2. So this is problem number 1 for your problem inventory for test 2. This is a pretty good problem that I came up with. It makes you guys do logarithm stuff again. So all I'm going to do is we have our dA, so you can change the order of integration because it's an iterated integral. You're allowed to swap the order of integration to whatever you think is convenient. But the one thing I don't like when I'm looking at this is that there's a y as an exponent in there, and that's going to make everything a little bit harder. But there is an exponent rule that lets us do something clever, which is going to let us go from 1 to e, and then we're going to go from 0 to 1. This is the y values, and we're going to say this is y ln of x. This is a logarithm rule that allows us to pull this guy down in front. And we'll just specify that we're doing dy by dx, okay, for our areas. And you can, as long as you swap these orders of integration, you can swap these orders, and there's no penalty to do so. So let's go ahead and integrate that. Right now, natural log of x is considered to be a constant. So we're just integrating with respect to y. So we're going to get 1 to e. We're integrating with respect to y. So we have y squared over 2. We have our ln of x. We've integrated with respect to y. So I'm just going to skip writing that from now on. And then we're just going to write from 0 to 1. Let's go ahead and evaluate those limits. So that's going to be 1 squared, which is 1 over 2 minus 0 over 2. Just evaluating my limits. Y goes from 0 to 1. Here's our limits from 1 to e, because I haven't integrated the natural log yet, dx. And that's what we're kind of dealing with. Now, if you remember, and I won't let you forget, that you can't integrate natural log. You have to go ahead and set up an integration by parts. So we're going to say integration by parts here. Okay, you could abbreviate it, whatever, but we're going to say, let's go ahead and let u is equal to the ln of x. Du, because we couldn't integrate it, is 1 over x. dv is just dx, and v is just equal to x. And then we go ahead and do our little box thing that we have here. So we're going to have x ln x times, or minus rather, the integral of x times 1 over x. So if you don't mind, I'm going to go ahead and reduce this 1/2 minus 0 to just 1/2. Okay, and then we are going to be dealing with the integral of natural log of x. But since we've kind of started working on this, it's just going to be x ln x minus the integral of x over x dx, as well. X goes from 1 to e. Okay, no, we don't have to worry about improper integrals. We could have, but we don't have to worry about that in this problem because everything is good. So we're just going to get a 1/2 times the whole thing when we're done. We have an x ln x. This thing cancels off to 1, so we're just going to integrate dx of minus x going from 1 to e. And then now we have the hard part of the problem. We have 1/2. And I'm going to type in e natural log of e minus e. That's x evaluated at e. You can say that. Minus, and then we're going to have 1 ln of 1 minus 1. And this is x evaluated at 1. Okay, let's see what we end up with. So we have our 1/2 sitting outside here. So that's not going anywhere. Okay, and then we have e times the natural log of e. That's just e. Natural log of e is 1. Minus e. Well, that's odd, but that's going to be 0. Minus, and then the natural log of 1 is going to be 0 minus 1. So this piece here goes off to 0. We have a negative of a negative, so we just end up with 1/2 times 1, which is 1/2. There you go. So that is how you deal with that integral. Do expect that in a basic iterated integral that I could very well put in something that requires you to do integration by parts in here, just so that we don't forget that we learned that. It will come back. It's a very powerful technique. So it's something that may happen over and over and over again. So I'm going to let you guys go with that video. We'll keep them really short and just do like one problem at a time. So thank you for watching. Good luck on the exam, everybody.